Okay, any questions on that? Okay, I really hope that makes sense to everyone. So let me just zoom this out. So I guess everyone can see, right? So again, here, right, we have the compound inequality. We get x, we want to get x all alone. Here, we have to turn the inequalities around because again, we're dividing by -4. Excuse me, we're dividing by a negative number. When you multiply or divide by a negative, you have to flip the inequalities. All right. Okay, so now, let me now get to the new notes then. Okay, so I'll start the next section, which is 1.6. I'm going to share that. So here, what we're going to do is we're still going to look at inequalities, but now what we're going to do is we're going to look at inequalities with absolute value. That's what we're going to look at here. So in particular, we're first going to have to see what the absolute value of a number is. Okay, and I will define that. Actually, I'll define it in two different ways. We're also going to see how to solve, equations that involve absolute value. And we're also going to see how to solve inequalities with absolute value. Only some inequalities. Basically, previously when I've taught this course, I would do all kinds of inequalities with absolute value. For time consideration, I'm not going to do that, but you'll see what I mean. Okay, so let's define absolute value. So for any number here, b, okay, for any number b, by definition, the absolute value of b, it's denoted by this, as you can see. You have two vertical bars, b is between. This is defined this way. That's how this is defined. So this is saying the absolute value of that number b, whatever b is, it's going to be b itself if your b is non-negative. So we're going to get b itself back if b is non-negative. But we get back negative b, which is -1, negative b, if b, however, is negative. I know it's a little strange. This is actually how it's defined. So it depends on if b, the input, is greater than or equal to 0 or less than 0. As an example, if you calculate the absolute value of 1, right? That's going to be 1 itself. You get back the number itself. And why is that? Well, 1 is non-negative, right? This is saying the absolute value of a number b, that's going to be b itself if that b is non-negative. So in this case, b is 1, since 1 is non-negative. Now, what about -1? The absolute value of -1? Well, you're going to get back negative that number. Negative that number. In other words, you're going to get back negative that number, which is actually 1, right? This is saying you get back negative b if the b is negative. So you get back negative that number if that number is negative. So in this case, we're actually going to get back 1 itself, since -1 is negative. Okay, that's probably confusing. I understand that. I mean, hopefully my explanation helped. But there is another way to think about absolute value. It's also distance from 0 along the number line. And that's what I'm trying to show you here. That definition is a little bit easier, maybe because it's more intuitive, I don't know, but it just happens to be a little bit easier. But the absolute value of a number is how far that number is from 0 on the number line. So a number b, its absolute value is just b itself if b is to the right of 0. Because again, b from 0 is b units. With negative b, it's the same idea. The absolute value of negative b, that's the distance between negative b and 0. But that's also b units. You're just going to the left. All right. So as an example, what would the absolute value of 3 be? Well, that's going to be 3. Now, why is that? Well, 3 is 3 units away from 0, right? Here's 1. Here's another unit. And here's another unit, right? 1 is, let me fix that. 1 is 3 units away from 0. 1 is 3 units away from 0. So the absolute, 3 is 3 units away from 0. That's what I meant to say. So the absolute value of 3 is 3, as you can see. The absolute value of 1, well, that's just 1, right? Because 1 is 1 unit away from 0. What about negative 2? Negative 2, that's the okay, so the absolute value of negative 2, well, negative 2 is 2 units away from 0. It's just to the left instead of the right. So negative 2 has absolute value 2. So it's 2 units from 0. So that's what we get here. Okay, good. So again, when you think of it in terms of distance, it's a little bit easier, maybe because it's more intuitive. So good. Notice though that 1 and negative 1 have the same absolute value, right? Negative 1 is 1 unit away from 0, to the left of 0, but 1 is 1 unit away from 0. It's to the right of 0. So negative 1 and 1 have the same absolute value. All right. We can also consider equations involving absolute value, such as the absolute value of x equals 2. Let's say we wanted to solve that equation. Let's say we wanted to do that. Okay, so what is this really asking us? Well, the solutions to this equation, right? We want to solve it. We're looking for the numbers you can plug in for x that make the equation true. That's what we're looking for. We want the numbers you could plug into x, that make the equation here true. Okay. What numbers do that? Well, we know 2 works. And why is that? Well, again, 2 is 2 units away from 0, right? This is really saying the absolute value. So this is asking for all numbers x whose distance from 0 is 2. 2 is a number that does that. So 2 is a solution. But is that the only one? Well, you can see from here, no, because negative 2 is a solution. Negative 2 is 2 units away. It's just to the left of 0 instead of the right. So this equation has 2 solutions. It has 2 solutions, right? 2 and negative 2. Okay. All right. Okay, so let's see. With 3, it's the same idea. You want all solutions to this equation. So you want all numbers that you could plug in for x that make this equation true. That is, you want all numbers whose absolute value is 3. There's two of them. We have 3 and -3. So we'll pick up from here next time. You know, we're running out of time, so let me stop the recording.